the largest black hole ever discovered. There is something in the universe so massive that calling it a black hole almost feels inadequate. It contains billions of times more mass than our Sun. Light cannot escape it. Entire stars can disappear beyond its boundary. And from where we are on Earth, the scale of this object is almost impossible to imagine. Its name is TON 618, and it is one of the most extreme objects ever discovered in the known universe. But just how big is it? To understand that, we need to start much closer to home. Our Sun is enormous compared with Earth. You could fit roughly 1 million Earths inside it. Now, imagine compressing several suns into an incredibly small region of space. The gravity becomes so intense that nothing can escape. Not matter, not radiation, not even light. This is a black hole. But black holes come in very different sizes. Some are only a few times more massive than our Sun. Others sit at the centers of galaxies and contain millions or even billions of solar masses. These are known as supermassive black holes. At the center of our own Milky Way sits Sagittarius A star. It contains about 4 million times the mass of the Sun. That sounds enormous. And it is. But compared with TON 618, it is tiny. TON 618 is an ultramassive black hole associated with an incredibly bright quasar billions of light years away. Current estimates place its mass at tens of billions of times the mass of our Sun. Think about that for a moment. Not tens of billions of Earths, tens of billions of suns. And because a black hole's event horizon grows with its mass, TON 618's scale is difficult for the human mind to process. The event horizon is the boundary surrounding a black hole. Cross it, and there is no known way back. For an object this massive, that boundary would span an enormous region of space. If something like TON 618 were placed at the center of our solar system, its event horizon would extend far beyond the scale of the inner planets. The world we know would simply disappear inside it. Earth, Mars, the asteroid belt, and much more. All of it would exist inside a region from which light itself could never return. But here is where the story becomes even stranger. We do not actually see the black hole itself. Black holes are, by definition, dark. Instead, astronomers detect what is happening around them. TON 618 powers a quasar. A quasar is an extremely bright galactic core fueled by material falling toward a supermassive black hole. Gas and dust spiral inward. The material heats to extraordinary temperatures, and before it crosses the event horizon, it releases enormous amounts of energy. The result can shine brighter than entire galaxies. Imagine an object so dark that light cannot escape it. Yet the chaos surrounding it creates one of the brightest beacons in the universe. That is the contradiction at the heart of TON 618. Darkness surrounded by unimaginable light. But how could a black hole ever become this large? That question is still difficult. Black holes can grow by consuming matter. They can also grow by merging with other black holes. Over billions of years, repeated feeding and mergers can create enormous objects. But some of the most massive black holes in the distant universe appear to have grown remarkably quickly. And that creates a problem for astronomers. How did they become so massive so early? Did they begin as the collapsed remains of the first generations of stars? Did enormous clouds of gas collapse directly into massive black hole seeds? Or is there something about early black hole growth that we still don't fully understand? TON 618 is not just a giant object, it is also a clue. a clue about how galaxies evolved, a clue about the early universe, and perhaps a clue that our understanding of black hole growth is still incomplete. Now imagine approaching it. From far away, you might first notice the brilliant region around the black hole. The closer you travel, the stranger the universe begins to look. Light bends. The background sky becomes distorted. Space and time behave in ways that don't match everyday experience. But for a supermassive black hole, something surprising happens. The tidal forces at the event horizon can be less extreme than those around a much smaller black hole. In theory, you might cross the event horizon of an enormous black hole without immediately noticing the exact moment you crossed it. There would be no wall, no solid surface, no flashing warning sign. But once inside, your future would point inward. Every possible path would lead deeper toward the black hole. Escape would no longer be possible. Eventually, according to our current understanding, you would encounter conditions where our known laws of physics can no longer fully describe what happens. General relativity predicts a singularity. Quantum physics suggests the full story may be more complicated, and this is one of the greatest unsolved problems in modern physics. What truly happens at the deepest interior of a black hole? We don't know. And TON 618 reminds us just how enormous that mystery can become. The universe contains planets larger than Earth, stars millions of times larger than our planet, galaxies containing hundreds of billions of stars. And then there are objects like TON 618, objects whose scale challenges our ability to imagine them. From Earth, our daily problems can feel enormous, but somewhere across the cosmos sits a black hole with tens of billions of solar masses, a place where gravity dominates space and time, a place surrounded by light powerful enough to be detected across billions of light years. And perhaps the most incredible part is this. TON 618 may not even be the largest black hole that exists. It is one of the most massive black holes we know about. But the observable universe is vast. There may be even larger objects waiting to be discovered. TON 618 is not the end of the story. It is simply the largest chapter we have managed to read so far. If you enjoyed this journey into one of the universe's most extreme objects, subscribe to SciVortex for more explorations of space, physics, and the mysteries of the cosmos. Because every time we think we've discovered the limits of the universe shows us something bigger. If the universe fascinates you as much as it fascinates us, subscribe to SciVortex. There's always something bigger waiting to be discovered.